So my name's Peter. I'm an Elixir developer. I've got about 2.5, 3 years of experience, somewhere in there. Building everything from really cool big shit to just day-to-day updating HTML, templating things, which that can be cool too, but it's not as, doesn't get to the meat of why we like Elixir. So today I'm going to do an intro talk. It's very introductory. This is for people who have not seen Elixir or who have heard, they're like, oh, it has pattern matching, that's why we love it. But they're like, I don't know what the hell pattern matching is, or I have a general idea, but I understand it's probably not fancy regex, which it's not. Regex is also in Elixir, obviously, but it's just as much of a pain as it is in any other language. So pattern matching, and then we'll go a little bit over the debugger. That part's going to be a little bit live, just because otherwise it's not very fun, and also because I haven't touched this talk in a month, and I never really got the debugger part done. So let's get going. I'm Peter. I'm Felix Starman on almost anything. Depends on whether they take underscores. If they don't, it's dash. The slides for this will be on GitHub at Felix-Starman, and then what is pattern something. And parts of this are taken from Elixir cones. If you don't know what that is, the cones spelled like that is just a way to like practice and meditate on introductions to new languages. The Elixir ones are pretty good. They're basically like the fundamentals of what the language provides. So let's talk about pattern matching. And as part of that, what most languages would call assignment. So in JavaScript, if you want to set a variable and maybe redo it, you'd have let some variable, and then you'd maybe have a list. So in this case, it's menu item, it's number 37, it's the crunchy frog. In JavaScript, if you wanted to assign it, you'd use let. In Ruby, you can just say some var and make a list out of the same stuff. Elixir is exactly the same. This is nothing new here. And some languages also allow multiple assignment. They call it different things. So in JavaScript, they call it destructuring assignment or just destructuring. If you've got the thing on the right that you care about and you want to assign it to multiple variables without having to do 3, 4, 5, 6 lines or digging through maybe a JSON object, in JavaScript, you can do it like this. You can also do it with JavaScript objects. That's probably what most people are familiar with if you are familiar with JavaScript. In Ruby, they call it multiple assignment. It works the same, pretty much. The only difference is you can really only do multiple assignment with arrays. That's it. I don't think they have multiple assignment for anything else. They just introduced pattern matching to Ruby. I think it's in release candidate. If I remember, it looks like trash. And you will look at it and go, why the hell would I use that? That looks horrible. Some of that's just going to be hiccups with whatever. Doesn't matter. That's not the talk today. So yeah, in Ruby, that's called multiple assignment. It's useful for lists. You're mainly going to see this when you're going through a loop of a function, and you need to say, grab the key and the value. You'd see that definitely when you're iterating through a map. I wish I had thought to put that in code here to give you an example. In Elixir, it pretty much looks the same, but it's working very differently under the covers, hence, quote, assignment at the bottom there. Because it's actually called matching, and it happens to assign as an afterthought. And let's get into that. So it's not quite assignment. And the reason why is what's actually happening is you have a thing on the right, which is some term that you care about. That's what they're called in Elixir, is terms, just data structures. And then on the left, you have some undefined variable. The language basically looks at this and says, that's not a thing I know about. It's not been set. I will make sure that there's nothing else to match against, and then I'm going to make a variable in memory called favFruit, and then set whatever's on the right to the left. The reason why I bring up about if there's anything else to match against, you'll see in a sec. So if you've got favorite fruit, I like Honeycrisp and Granny Smith in that order. You can do some interesting things, which is if you then say, let's say later on in your program, you need to get just what the apples are. You don't care about anything else about this user's favorite fruits. I might like kiwi, I might like other things. But you just say, I just need to get the apples. Well, then you can pattern match like this and say, get the apples, and assign it to the apples unbound variable. And that's what it does here, is it binds a variable called apples. And the way it does that is by pattern matching and saying, okay, I've got curly squiggle brace, which is map or hash or object in other languages, but here it's called a map. It has some key called apples and some value. I don't know what the value is. It could be nil. It doesn't matter. I'm going to set it to apples. Or I'm going to set apples to whatever that variable is. I can move the podium if that's easier. Sorry about that. I forgot about speakers and shit when I was like, oh yeah, just left justify everything. It was like, it went like this. It was giving me code blocks going like this, and I was like, why would you want that? Who wants code blocks that go like this? So, anyway, you can then when you say, okay, what's apples, the output is Honeycrisp and Granny Smith. This is just like JavaScript destructuring, except it's a little bit more verbose. Because you can grab more than just keywords and values. But let's say you want to check somewhere else in your function or in your code. Okay, I don't really care. I just want to know, do you like durian? Because that's what I really want to know is I want to send you durian as a joke. And if you like durian, you're not going to find it funny. You're just going to say, oh, thanks for the durian. I love that. And you're like, oh, that's pointless. I don't want to waste $10. Durian's expensive. So you say, okay, well, if durian is true, don't do anything. You're not going to like it. Or maybe, let's say if this was false, then you'd say, oh yeah, I'm going to send you durian now, or sneak it into your recipes. Well, this, just blank by itself without a rescue or something, is going to throw a match error. Because I did not say I like durian, because durian is gross. It smells pretty gross. Maybe there's certain dishes that can be a good accent, but in general, by itself, not part of a favorite meal, but just by itself, not good. So it'll say match error, and then it'll give you what the actual value that you were trying to match on the right-hand side is. If you've written Elixir and you've run into a bug, you've probably seen this. This is, I want to say, the most common. This is the undefined function of Ruby, or the not a number of JavaScript, is match error. You see it always. But there's other types of matching, pattern matching, and assignment. But sometimes if you just need to pattern match and you don't care about the assignment, you can use an underscore like this. So if you're dealing with a map, let's say you've got some very gigantic user session object in memory that's whatever their session cookie is. And you say, and your system is set up such that if they have a username is part of their user session, then they are a logged in user. That's like you can trust that they're not going to be able to mess with their session and add a username as a key value because that would be cryptographically unlikely. So you can just say, I don't actually care who they are, I just care that they're logged in. You want to take them to the logged in user dashboard. You want to show them different things, just like welcome to blah, welcome back so-and-so, or maybe welcome back, here's something. But if you just want to say, are they logged in, I don't actually give a shit about what their username is, you can do that. You can just say username underscore. The value doesn't matter. The username, the existence of that key is what I care about. And that's a valid pattern match, and you use it all the time. You probably use other things around it, like if or some other type of keyword, but that's what you use. But you might also have things like username where you don't care, and you say, are they an admin? Or you might say specifically, if this person is, I've done this, unfortunately, this person is the admin user, and you go in the database and you look up your own username, and you're like, I don't really want to code in really like verbose, or I don't want to code in really good auth logic. I just want to say, hey, if the username is me, then let me in. So you might commit your own username to the database. Don't do that. But if you do, this is how you do it. So that might be something that lets you into some protected page. Or you might use something like the pin, which we'll not get into because it's a little bit more advanced. The pin operator lets you use a pre-existing variable on the left-hand side of a pattern match so that you can use it as a match. This would be exactly the same as if current user was Demosthenes. If Demosthenes was the current user, or the author in this case, I could use that as part of this pattern match. And this is really useful when you need to do, hey, is this person the owner of this article, or the author of this article? You can do pattern matching on other data structures. The big one that it's what sets it apart as fairly distinct between Elixir and Erlang, which Elixir and Erlang share the same VM, is string matching. Strings are binary lists, I want to say underneath, or is that char lists? That's char lists. Anyway, but the point is you can do pattern matching like this, where if you know what the first couple characters are, you can use that. And this is really useful when you're doing really low-level implementations of protocols, such as like HTTP or FTP, or something where all you know is you have a buffer of bits and you need to figure it out, figure out what to do with it. It's very standardized. You can also do it with lists, like I showed you, such as this, like, let's say you've got some basic auth. You can split into username and password. And then you can pattern match on explicitly a list that is only 2 elements long. That way, if someone somehow sends in like a, oh, I forgot to say split colon here. Oh. That's what I get for not actually running my code before putting it in slides. But if I was splitting on colons here, that way, if someone threw a colon into the middle of their password for some reason, you would get 3 elements, it wouldn't match, and it would blow up. Don't trust that. Do more than just that. But if you were doing that, this would catch it. You can also match on tuples. If you're not familiar with tuples, they are like a fixed memory size element. They're a certain number of elements long. They can be any mix of things. Not quite the same as lists, because those are linked lists. But that way, you could use something like OK, the OK atom here, which is idiomatic for Elixir and Erlang to use OK as the first element of a tuple to say, yep, it's done, it didn't blow up, versus error, and then whatever the error message is. So you can use OK, grab the result from some function that's very important, and use that as a error check. And then that way, during runtime, if something comes back with error, you can just go, well, yeah, it's important to catch errors, but I really just need to protect against the positive side of this. And if someone sees an error page, that sucks. I'll get a bug report, and I'll fix it. But until then, I'm just going to do this pattern match. So one of the biggest places that you'll use pattern matching, though, is in functions. You'll use them in function heads. So function heads are the def, my function, and then the rest of it. Like this first line up there, def authorized con. That's a function head. In this case, I only have one function definition, and so I only have one function head. But if I were doing an authorization function where I'm taking a connection and then saying like, okay, somewhere higher in the stack, someone checked that the user, who they were, and they threw their username in, and they said, oh yes, they are or are not an admin, and I set the current user, and I set the owner of the resource that I'm looking at. Let's say you're looking at some article, and it's going to say, oh, the owner is not you. It can go through, you can say if con admin true, because you always let admins through. And then otherwise, you do the rest of your shit. So in this case, you'd have, are they the owner, or is the current user the owner? Sure, let them through. Otherwise, throw them out. But this is really ugly. It's not very nice to look at. And it very, very, very quickly becomes overloaded. And if you're not careful and you use this function for lots of pages, so let's say someone says, oh, I want this to be on the articles page, on the article edit page, but I also want it to be on this other page, but I have slightly like admins or editors, or owners or editors. And then suddenly you add another if that says if con.owner equals current user or editor, but you only want to do it on one page, which is the edit page, not on the delete page, because editors can't delete articles. They can only edit articles. That's a pain in the ass. Instead, you can just do this, which is write function definitions with multiple heads. So in this case, and it's evaluated from the top down, are they the admin? This is taking a con. Are they the admin? Then return true. Are they the current user? And you can notice in this case, it says owner, user, current user, user. That's binding and matching to the same variable. So the first time it says owner, bind that to user. Current user, is that already bound? If it is, check that it matches. So it's doing matching within the match to say the user is the exact same user. Then return true. Otherwise, return false. And that's a really, really tight, little three-line function, because this is like one function with three function heads. This is a tight function that lets you break down really nested, ugly code into exactly what you care about. And for really recursive functions, it might be a pain in the ass, but for things that are lots of if and else, it's a lot easier to read. So you can do things like that. And this is where you'll do it 90% of the time. You'll use pattern matching here. So let's talk about debuggers. Let's make things a lot bigger. Oh, my elbow's on this thing. Books. CD banana. Cool. All right. So if you are familiar with Elixir, you're going to read this and go, I know where it's going to blow up. If you're familiar with Elixir, and you look at this for a minute, you'll go, he's told me it's bad. It's going to blow up. Let's figure it out. But let's see, IEx-S, mix. So IEx is the interactive Elixir command. -S, I don't remember what it actually tells it, but it's basically, hey, I want to actually load something else. And then mix is the default function to say, hey, go look at the mix.ex file and load whatever it tells me to load. In this case, which is lib banana. So I have banana here. You can see it has peel as a function. And I can, in this case, because I have a struct, which you don't need to know for the purposes of this talk other than it is a standardized data structure, I can say struct banana to make a banana struct with the default size of 3, which I actually don't know if biologically it's 3 or 4 sides, because I never actually think about it when I peel bananas. I can pipe it to banana.peel and watch it never return, because it won't. And the reason why is because functions are evaluated from top to bottom. But if I don't know that, I might say, okay, what tools do I have in the debugger to figure this out? Because I can't stop the system and go through and figure out what's with banana peel while it's going through the loop. Technically you can, but you'd have to know some Erlang and know some observer and know some other things and hope that you have a multi-core system, because then you could, but it won't actually let you look at this call. It'll let you figure out the code. Anyway, it doesn't matter. So you can do things like use IEx. Might kill that. Require IEx. And then say IEx dot pry. If you're familiar with Ruby, that's why it's called that. Is there's a gem called pry in Ruby. So you know that it's probably happening with this iteration, or with this recursion here. So you'll put it right before the recursion. And you don't know, just in case, for some reason, why it's happening here. You just decide to put it down here as well. Let's put yum. Oh, these weird chiclet keys. So you do this. Struct banana pipe to banana.peel. And you get the first IEx stop. So this asks, do you want to stop? You say yes. Oh, no, you don't. Break reached. Wait. Where am I? Oh, I guess it just stopped automatically because I'm already in IEx. I'm used to that. If you run this in Phoenix, it will ask if you want to stop. In this case, I'm already in IEx, so it stopped. So I can say, oh, okay, continue. That's weird. I'm here again. Okay, continue. Continue. And yeah, it keeps going forever. That's when you go, oh, okay, I have written something poorly. I probably need to put this function above this one so that it will pattern match on the first one before the second. And that way, if the sides are 0, don't keep recursing. And continue, continue, and it's done. And it stopped. And we fixed it. So there's a lot of other cool things about IEx. You'll probably use IEx pry about 90% of the time. There's a lot of helpers built into it. So for example, you can say h, let's say h enum.sort/2. It will give you the docs of the help for enum.sort/2 function, or you can say /1, and it'll give you those. You've got IEx.helpers, and all of these. These are things you can call in your IEx shell. The nicest one is v. So if I would say v0, that'll tell me, no, it won't. 1, 2, shit. Well, it should tell you what the output was on that line of your pry session. Oh, it was help, that's why, because I don't actually have any output on that, because it's a put statement. So there's a lot of really fantastic things in IEx. I suggest taking the docs a look and then just messing around with it. No, I don't want to upgrade. I just paid for it a year ago, and I don't want to pay for it again. Not yet. So there's a lot of really great ones. LS and where am I is fantastic. If you're ever 10, 20 lines deep through your IEx and you're like, wait, where the hell is my break again? You can say literally, where am I? And it will post where the break was placed. You can do print working directory. That will tell you, I think, the working directory from where the process was called. Recompile is fantastic also if you don't want to leave IEx, but you changed something and you need to recompile your module. So for example, if I fixed the thing, I could say r banana, and it has recompiled and reloaded banana, and I can use it again. There's a lot of cool shit. One that I have not used, but someone told me about was break. This thing is fantastic. I am sure it will save my ass someday. But you can give it the arity of a function, and it will break no matter where it is. So if I've got 15 peels, if I've got 15 versions of peel, I don't know, you're peeling a bunch of bananas for some reason, or a weird genetically modified 15-sided banana for some reason. Instead of doing IEx pry 15 damn times, you just say IEx break banana.peel/15, and no matter where, it will stop if you call banana.peel. And it will tell you with where am I, where you have stopped. So take a look at the debugger. If you're interested in more Elixir intro stuff, take a look at Elixir cones. They're fantastic. And if you want to review this at all, take a look at my GitHub. And I'll be pushing these up tonight. So any questions? No? Everybody's an Elixir wizard? It's a joke. There's a podcast called Elixir Wizards. It's bad. That was a bad joke. All right.